So is my screen visible to you?
Yes, sir.
Yeah, voice is clear?
Yes, sir.
Okay. So last class we were seeing instantaneous velocity. Okay. Can we just revise? So what we have seen in instantaneous velocity? What is instantaneous velocity? Yeah.
Velocity at particular instant of time, sir.
Yes, velocity at an instant. Okay. Velocity at an instant. Very good. And its unit is
Meter per second.
meter per second. Very good. Then the definition for instantaneous velocity. So the definition for instantaneous velocity, instantaneous velocity, I'm writing it as I dot v. Okay. Is defined as the limit or limiting value. Okay. Limit or limiting value of the what? Average velocity. Right? Instantaneous velocity is defined as the limiting value of the average velocity as time interval, del t approaches 0. So this is the definition, right? Do you remember?
Yes, sir.
Yeah. So what can we write? V is equal to, we are applying limit to the average velocity. So limit to the average velocity is what? What is average velocity formula? Come on. What is average velocity formula?
Delta x
Total
divided.
displacement divided by total time.
Total displacement divided by total time, or just a moment. Good evening, Disha. Welcome to the class. Okay. So yeah, what is
Good
average
evening, sir.
velocity? Good evening, Madisha. So what is average velocity?
Delta x divided by
By
delta
delta
x.
t. Delta x nothing but,
Rate of change of displacements.
yeah, displacement, right? Delta is what? Displacement. Displacement means what? Change in position, right? So change in position is nothing but del x. This is position. Position is nothing but x. This delta is nothing but what? Change. Okay. So del x by del t, that is as del t becomes 0. So what happens here? So we know that v is equal to limit of del t becomes 0. So that is of del x by del t, taking limit of del t tends to 0. So it happens like what? Dx by dt. So what is this? Differential coefficient of x with respect to time. Differential coefficient of position. Okay, with respect to time. So it is, in turn defined as rate of change of position with time, right? Rate of change of position with time. So you guys remember this, what we have seen in the last class? Okay. So yeah, rate of change of position with respect to time, actually at that instant. Okay, at that instant we have to. So what about that d? Which d, ma? Disha?
So I have written dx by dt. There,
Yeah,
one d.
yeah, we are differencing the position, okay, with respect to time. That is what. So here, what do you mean by this, Disha? This tells us that the change in position, okay, change in position, okay, within a time interval. You understand? Here, this dx is nothing but change in position, okay, and this dt is nothing but at that instant. Now clear? Now are you clear? Yeah, excuse me, ma, just a moment. Hello, yes, sir. Yes, sir. Just a moment. Yes, ma'am. So you guys clear with this? Disha, no? Disha, you're clear? Disha?
Yes, sir.
Yeah, you're clear. Okay, okay. So yes, and the next we are seeing is we see an example sum. Okay. So here they have given a portion of an object. Okay, they have given a portion of an object along x-axis. They have given it as an equation. Okay, that is x is equal to a plus b t squared. Okay, and a and b are constants actually. A and b are constants. Okay, a and b are constants, and they have given a value for this constant. Okay, they have given a value for this constants. Okay, where a is equal to 8.5 meters and b is equal to 2.5 meter second squared, sorry, meter second. Okay, and t is measured in seconds. So they're asking what is the velocity. Okay, what is the velocity at t is equal to 0 seconds and t is equal to 2 seconds. So they have given position in the form of equation. Okay, they have given a position of an object. Okay, now we have to find out the velocity. Okay, so how do you find out the velocity? V is equal to instantaneous velocity. V is equal to dx by dt, right? See, they are not asking average velocity. They are asking only velocity. That means instantaneous velocity. Okay. So V is equal to dx by dt. So d by dt of what? What is the x? X value, that is a plus b t squared. Okay. So now we have to differentiate. Okay, so when you differentiate a constant, what will happen?
It becomes 0, sir.
Very good, it
0.
becomes 0. Okay, so a is 0. Here we cannot differentiate b. Why? Because we are differentiating this equation with respect to what? Time t. Okay, so you can only differentiate this one. Here it becomes 0. Okay, and when you differentiate here, you cannot differentiate b, so it is going to be there. Okay, when you differentiate t squared, what happens? 2t, right?
Yes, sir.
Yes, and it becomes 2bt. Okay, so velocity is nothing but 2bt. And in the given, they have given just a moment. Some student is joining right now. Just a moment. Samantha, welcome Samantha to the class. So we were discussing, we are in the chapter motion in a straight line. Okay, hope you can follow. Okay, so here we have found out velocity. Velocity is equal to 2bt. Okay, and the question they have given b value, that is 2.5 meter per second squared. So that is b is equal to 2 into 2.5 into t. So v is equal to what? 5.0 t. Okay, so this is velocity equation, not the velocity value, it is a velocity equation. Okay, like position, which is given in a equation format, velocity's value is also given in a equation format. Now they are asking, what is the velocity at t is equal to 0? When t is equal to 0 seconds, excuse me, another student is approaching, just a moment, sorry. Vishwa, welcome to this class, Vishwa. Yeah, so when t is equal to 0 seconds, what is the value of velocity? As you know, so when you substitute this value in v, that is v is equal to 5.0 into 0, it becomes what? 0 meter per second. So when t is equal to 0 seconds, velocity is equal to 0 meter per second. Now they are saying what is the value when t is equal to, I cannot delete this. So when t is equal to 2 seconds, so what is the value of velocity they are asking? To substitute this in the velocity equation, that is v is equal to 5.0 into 2. So that is nothing but 10 meter per second. So when t is equal to 2 seconds, velocity is 10 meter per second. Sir, how does b2 squared? Yeah, Disha, I'll explain it once again. Huh? Disha has a doubt. Okay, I'll just explain it. Yeah. See, we have an equation that is x is equal to a plus bt squared. Okay, it is given a plus bt squared. Okay. Now to find out velocity is what? Dx by dt. That is, we are differentiating position with respect to time. So that is nothing but d by dt of what? This is x value. So that is, I'm substituting, that is a plus bt squared. Now you can write like this, that is d by dt of a plus, okay, d by dt of bt squared. Okay, so always remember, while you're differentiating, okay, when you're differentiating a constant, a and b are constants. Okay, in this question a and b are constants. Okay, so when you're differentiating a constant, it is nothing but 0. Okay, so a is a constant, so we are differentiating a with respect to time, that is t. Okay, so it becomes what? 0. I'm writing this here, it becomes 0 plus, when you are differentiating bt squared with dt, that is with respect to time. So when you differentiate b with respect to time, you cannot differentiate b with respect to time. Okay, so this constant will be like this. Okay, this constant will, what will happen, it will not become 0. Okay, When it can become 0, for example, well, b plus t squared, this is for example, okay. If I differentiate like this, what will happen, this b becomes 0 because it is it is in the addition format. So this become b becomes 0. Then I will differentiate only plus d by dt of t squared only. I will not bother about this one. But when I am when I am just differentiating bt squared, which is in the multiply format, okay. So this constant, which is in a multiplier format of t, okay, when because this is the whole term, okay. So when I differentiate b plus t squared, this is one term and this is one term, you understand. But here bt squared is a whole term. So when I differentiate this whole term with respect to t, I have to keep this b like that only. I'm not going to, we cannot differentiate b, so b will be like this, okay. And t squared, what is differential, uh, that formula, the differential formula, right? That is na into n minus 1, right? So that is d by dx of a, what will come, that is n, a power n, sorry, d by dx of a power n is nothing but n into a power n minus 1. You know this, no, Disha? Class 11 students, are you familiar with this, the differential format, the process of
No, sir.
differentiating? You're not familiar, okay. So I'll just tell you. So when you're let's say this is, it's not okay. So let's say this is the format actually, okay. D by dx of, okay, let's say x squared, we are differentiating x squared, or this is a format, just copy down this format, then you can follow, okay. So d by dx of x power n is nothing but n into x power n minus 1, okay. N into x power n minus 1. So that is, uh, for instance, if we are like d by dx of x squared, we are differentiating x with respect to x means, so what will happen, in the place of n, there is 2 you have, okay. So what you will do, this 2 will come here, no, so that is 2, and this x, okay, power of n minus 1, that is 2 minus 1. So what happens, 2x. You get my point, Disha? Do you follow?
Yes, sir. Understood, sir.
Yeah. So when we are doing bt squared, you know, so when you're doing bt squared, what happens, b will stay as such. So with, you are differentiating t squared with respect to t, so what will happen, this is 2t into 2 minus 1. So what happens here, b into 2t, which in turn 2bt, okay. Okay, so this is in turn 2bt.
Yes, sir.
Yeah, velocity is equal to 2bt. So yes, so we found out what is velocity is equal to bt, and we also find out what is t is equal to 0 and t is equal to seconds also. So when t is equal to 0 seconds, velocity becomes 0 meter per second. When t is equal to 2 seconds, velocity becomes 2 into, what is b, b is nothing but 2.5, right? B is nothing but what, 2.5, right, into t is 2, so it becomes 10, right, 10 meter per second, okay. 10 meter per second. When t is equal to 2 seconds, velocity is nothing but 10 meter per second, okay. Now find out the average velocity. You can find the average velocity actually, you yourself can do it. They're asking what is the average velocity between the time 2 seconds and 4 seconds. Can you solve it by yourself? So what is average velocity formula? That is del x by del t, which is nothing but x2 minus x1 divided by t2 minus t1. The position is given in this question, that is x is equal to a plus bt squared. You have the position, but you don't have the initial and final position, right? They have given a position as a equation. The position value has been given as an equation format. Now you have to find out what is the initial position and what is the final position. To find out what is the initial and the final position, they have given the time limits of time. That is, this is the initial time, that is t1, and this is the final time, that is t2. Okay, so to find initial position, to find x1, okay, to find x1, substitute t1 in this equation. So what is that? So x is equal to a plus b into, what is t here? T1 is equal to 2 seconds, right? So that is 2 squared. So what becomes, that is this is x1. Okay, so x1, that is the initial position, is nothing but a plus 4b. Okay, similarly to find x2, that is the final position, substitute t2, that is equal to 4 seconds in this position equation. Okay, so x2 is equal to what? A plus b into t2 is nothing but 4 squared. So it becomes what? A plus 4 4 16, 16b. This is x2. So you get my point, how we are finding out initial and final positions.
Yes, sir.
Okay, so now find out the average velocity. Now you can do. So what is x2 here? X2 is a plus 16b minus of x1 is a plus 4b divided by, what is t2? T2 is what? 4 seconds, right? 4.0 minus t1 is 2.0. Now tell me the answer.
So 15 meter per second.
15 meter per second. Okay. So it comes around what? 15 meter per second, right? Does everyone get that answer?
Yes, sir.
Very good. Do you want me to solve this problem? Anybody? Yeah, Mrinalini, thank you. Do you guys like, is there anyone who wants me to solve this problem further for them to understand?
No, sir.
Okay, okay, thank you. So, yeah. So here, so what we have found out, the average velocity is what? 15 meter per second, right? No?
Yes, sir.
Okay, so average velocity is what? 15 meter per second, right? And okay, one thing about, you know, so we know what is instantaneous velocity. Okay, instantaneous velocity, and we know what is average velocity. There is another quantity called instantaneous speed. Instantaneous speed, it is nothing but the magnitude of instantaneous velocity. Okay, magnitude of instantaneous velocity. It's always, instantaneous speed is always the, we can say it is always the magnitude of instantaneous velocity. For instance, if a body is moving in the positive direction, okay, let's say 0 to 20 seconds, and we are here, it is nothing but 10 seconds. If we find out the velocity of this body at this 10th second, okay, its velocity seems to be maybe 15 meter per second, plus 15 meter per second. This is what, this is what instantaneous velocity, right? Instantaneous velocity is nothing but plus 15 meter per second. So if we want to find out what is the instantaneous speed, okay, instantaneous speed is, okay, at this 10th second. So what is instantaneous speed here? 15 meter per second only. Okay. And for another example, let's say body is moving in the negative direction, 0 to 20 second, okay, in this negative direction, and we find the velocity of that body at 10th second. Here it seems to be 15 meter per second, minus 15 meter per second, okay, minus 15 meter per second. What is this? It is nothing but instantaneous velocity, right? What is the instantaneous speed here?
50
Yes,
meter per second, sir.
yes, instantaneous speed is nothing but 15 meter per second. So here it is plus 15 meter per second, since it is going in the positive direction, that is the instantaneous velocity. And here it is minus 15 meter per second, that is the instantaneous velocity, since it moves in the negative direction. But in the both the scenarios, the instantaneous speed is what? It is nothing but the magnitude of instantaneous velocity. So here also you are taking only the 15 meter per second. We are not bothered about the plus symbol. And here also we are not bothered about the direction. We are taking only the 15 meter per second for instantaneous speed. Okay, right. So we'll move to the next concept, next topic. Oh, actually you have a question here. First we'll solve this question, then we can move. Okay. So as you can see, this is asked in NEET. Okay, 2013. Okay. So in the question they have given a displacement. What is displacement? Change in position, right?
Yes, sir.
Yeah. And see, one thing you have to understand. This is a tricky question. Now it is all right. Okay. Now because we are dealing with motion in a straight line chapter only. Once you complete all the chapters, okay, and especially for NEET and JEE students, once you complete all the chapters and when you're writing mock exams, model exams, or even your NEET or JEE exams, so this kind of question could trick you. This is a easy question, okay, but it will trick you. Say what they have asked: the displacement x, okay, in meters of a particle of mass m. See, you have to underline this: mass m in kg, moving in one dimension, okay, under the action of force, okay, is related to time, okay, and they are given a equation, that is t is equal to root of x plus 3. And they are asking what will be the displacement of the particle, when its velocity is 0. What will be the displacement of the particle when velocity becomes 0? Okay, so they are asking that. And when you look at this question, uh, if you are a NEET or JEE aspirant, okay, it is easy, you know to get. It's a kind of a tricky question, so it is easily confusable actually. See, they have asked, they are given displacement, okay, of a particle, and they are given, they say of a particle mass m, they have given mass, okay, and they have given one dimensional motion under the action of force. Okay, so here they have given mass, okay, and they are given one dimensional motion. They are given one dimension. They are telling that the body is moving in one dimension. Okay, so what do you mean by one dimension? Anybody?
Along straight line, sir.
Yeah, along straight line. Very good. Okay. So while calculating motion along a straight line, do we include mass in that? Anybody?
No, sir.
Okay. And while calculating motion along a straight line, do we include force in that?
No, sir.
Yes, very good. Right? So this is how tricky it is. Okay. So what you when you come across this question, first you will think, you never think of straight line. This question is from straight line. You won't think of that. You will think whether it is from, it could be from laws of motion chapter, because they are given force. Okay. And what you'll think, it could be from work energy power also, because it has given mass. Okay, so this will confuse you. The one thing, okay, when they say it is in one dimension, okay, if it is in one dimension, always remember it is straight line only. So you don't have to care about mass, you don't have to care about force. Clear?
Yes, sir.
Yeah. So they are given, they are given a time equation, okay, and they are asking what is the displacement of the particle when its velocity is zero. Displacement is nothing but x. They are given here, no, the displacement x, okay. They are asking what is the displacement x, okay, when velocity is zero, okay. They are asking like that, when velocity is zero, what is the displacement? So displacement is nothing but x, but they are given the time equation, t is equal to root of x plus 3. Now you have to find out the value of x, okay. So take this 3 here, so root x is equal to t minus 3, okay. Now square on both sides, square on both sides. So when you square, root x the whole squared is equal to t minus 3 the whole square. So root and the square to get cancelled, so x is equal to what? T minus 3 the whole square. Okay, so now this is your displacement equation. You understand? This is your displacement equation. Now they
Yes.
are asking, yeah, now they are asking what will be the displacement of the particle when the velocity is zero. When velocity is zero, what is the displacement of the particle? So how to find out this? You know, we have to find out what the velocity is first. They're asking the velocity of that is the displacement of the particle. Tell us the displacement of the particle when velocity becomes zero. For that, you have to find out the velocity first. What is the velocity formula? Dx by dt. So here d by dt of, substitute this x here. So nothing but what? T minus 3 the whole square. So when you differentiate this, what happens? 2 into t minus 3, right? 2 into t minus 3. So what happens here? 2t
2t minus 6, sir.
minus 6, yeah, is equal to what? Velocity, right? So velocity is equal to what? 2t minus 6. You have find out what is velocity. They are saying when velocity is 0, when velocity becomes 0, what is displacement? So substitute as velocity is equal to 0. Substitute as velocity is equal to 0. When you substitute velocity is equal to, what happens? 2t minus 6 is equal to what? 0. 2t, take the 6 there, so is equal to 6. So t is equal to 6 by 2. So t is equal to what?
3.
3. So when velocity becomes 0, t becomes what? 3 seconds. So substitute that 3 in this displacement formula. What is displacement formula? X is equal to t minus 3 the
3
whole
minus
square.
3 the whole thing.
So x is equal to, t is what? 3 minus 3 square. So x is equal to 0. X is equal to what? 0. Okay. So which option is that? C. So displacement of
C,
the
sir.
particle. Yeah, displacement of the particle is 0. Okay. So you're clear with this sum?
Yes, sir.
Okay. So we'll move to the next concept. Okay, but we have some questions, I guess. Okay. Yeah, this is graphical questions. First, we look into that and we can go for acceleration. See, they are look at these graphs A to D carefully and state with reasons which of these can possibly cannot represent one-dimensional motion of a particle. They are given four graphs. Okay, you have to tell whether it is actually which of these cannot possibly represent one-dimensional motion. So in this, out of this four graphs, which of these does not represent one-dimensional motion and why? State that also. You can do this. Okay, one by one we can say. Yeah. Come on, students, you can do. Come on. Yeah. Just try, no problem. What about A? Whether it is a one-dimensional motion of a particle or not.
One dimensions.
A is one dimension. Your good name?
Jai Shri sir.
Jayashree. Okay, ma. Why? Why it is one-dimensional motion? Can you tell me? Okay, no problem. So A is not a one-dimensional motion. A is not a one-dimensional motion. Yes, anybody? Someone is opening their mic. Do you want to share anything?
Sir, no, sir.
Yeah, no problem. So here, see, Jayashree and others, just listen. Why it is not a one-dimensional motion?
Because it is passing through y-axis.
It is passing. They can pass through y-axis. That is not a problem. See here. So that y-axis is nothing but a position only. No. Oh, actually, it is position. Yeah. So y-axis they cannot go. Okay. Y-axis they cannot go. Right. And another reason. Yeah. You are right. Auxilia, right? Auxilia.
Yes, sir.
Yeah. And another reason is, see, let's say this is a time second. What this is? Let's say this is 3 seconds. This is third second. Okay. Here the body is at this position, right? Body is at this position at the third second. Similarly, the body is at this position, right? At the same third second. You understand? You understand from the graph what happens here? See,
Yes, sir.
yeah, so this is xt graph, okay, and here this is 0 something 0 to 10 seconds or something like this. This is third second. Now when I say like this, at the third second the body is at this position. Am I right or not? Okay, but here at the same, like this, at the same third second the body is at this position also. You get my point? So there are two positions at the same instant. There are two positions at the same instant. You getting it?
Yes, sir.
See, you're getting it. Let's say this is somewhat like 10 meter. Okay, so at 3 seconds the body is at 10 meter. Okay, and again at the third second it is similarly at the 20 meter. In one dimensional motion, okay, at an instant, at an instant the body or an object cannot be at two positions at the same instant, right? The body cannot be at two positions at the same instant. You get my point? Here the instant is nothing but third second. So body is at 10 meter, okay, and also at 20 meters also. So that is not possible, right? So is everyone clear?
Yes, sir.
Jay Shri,
Yes, sir.
you're clear, or do you have any doubts? No problem, you can share it.
Sir, could you please
Yeah,
repeat again, sir?
yes. So here, let's say I'll take an example here. So this is third second. Okay, I'm saying this is the third second. Okay, let's say this is 10 meters. Okay, 10 meters. Okay, so first just take a one-dimensional motion, that is a straight line. Okay, so this is 0 meters. Okay, this is 0 meters, and this is something somewhat like okay, this is 5, and this is 10, this is 15, okay, this is 20. These are all positions, Jayashri. Okay, the x represents the positions. You understand?
Yes, sir.
Okay, now I'm saying like the body started here, the body started here, okay, and maybe at 0 seconds or 1 second, something like that. Okay, 1 second. At the third second, the body reached the 10 meters position. You understand? The body
Yes,
is
sir.
at 10-meter position. So now here, let's say it started here. This is the origin. Okay, so the body is at, this is a 10 meter. Okay, so body is like here. Am I right? So the xt graph for that, this is uh, 3 seconds and this is 10 meter. So it is like this only, no? You understand, Jayashri?
Yes, sir.
Right? So this is the graph will be. The body is was initially at 0 meters. Okay. Now it has gone to 10 meters at 3 seconds. Am I right?
3 seconds.
Okay. Now here, if I say here in this third second, okay, there is another another curve also, it's there, no? Straight. Do you understand my point?
Yes, sir.
Okay. And so that is, let's say this is 20 meter. Okay. Right? Okay, this is 20 meter. So this represents that third second, the body is at 10 meter position. But in this graph, the body is at third second, the body is at 10 meters and also at here also, no?
Yes, sir.
Okay, so at third second, can the body have two positions? At 1 second, the body cannot be at two positions, right? So this is what first second, okay, and let's say this is second, okay, and this is the third second. At third second, if the body is like this, means your graph will be like this. That is xt graph. So it is 0 meters, then 10. Okay, so your graph will be like this. It is third. Okay.
Yes, sir.
Okay, but here when I say here also something there, means at this third second, okay, there's another position also involved. You understand?
Yes, sir.
So can the body have two positions at the same time? Can the body have two positions at the same time?
No, sir.
Yeah, that's what happens here. Okay, so this is for example only. For at third second, it is at 10 meter. Okay, I'm saying just because of the graph, or like you can say at this second, no, at this second, let's say this is 1 2 3, you have two positions at each second, no? Here also one position, 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 here also for each second. Okay, you have two positions. That is not possible in one dimensional motion. Okay, so that is why it is not here. So is it clear for everybody? Not only Jay Shri.
Clear, sir.
Clear.
Yes, sir.
Okay. What about B? Is it one dimension or not?
One dimensional, sir.
Who's that? Your good name, ma?
Jai Shri, sir.
Yeah, yeah. Oh, okay. Any other one? Jay Shri. Okay, good. What about others?
Not a straight line motion, sir.
Okay, not one dimension. That is auxilia. Anybody? Come on, you can try. No, this is just an interactive session. You are here to learn. That's all. Anybody want to try? I think I can call out. Yeah, thank you, Mrinalini, for your participation. What about Disha or Shruti? Can any of you participate? Okay. And this is also not a one dimension. Okay. Reasons?
It is traveling in a circle, no, sir.
Actually, see, it is a velocity time graph. It's not a position time graph. It is velocity time graph, VT graph. Okay. So x-axis, represents the time, and the y-axis it represents the velocity. So here, the same only. Uh, This is, let's say this is 2 second. Okay. 2 seconds. This is what. Let's say I'm telling this is something like uh, 20 meter per second. Okay. Okay. So at 2 seconds, what is the velocity here? At the second, what is the velocity here? I'm just assuming it is 20 meter per second. So what is the velocity here at that point? Come on, it is 20 meter per second only, no?
Yes, sir.
Okay. At similarly in this 2 seconds, there is also velocity in the negative direction. I'm saying that is minus 20 meter per second. You understand my point? Anyone?
Yes, sir.
This is one, and here also it coincides with the one velocity. It coincides with some velocity in the positive direction here. It coincides with some velocity in the negative direction here. So here at the at 2 seconds, here it is at 20 meter per second, and here at exactly 2 seconds it is minus 20 meter per second. So at an instant, 2 seconds is nothing but an instant, right? At the second, at that instant there are two velocities there, one in the positive and one in the negative. Is it possible or not?
No, sir.
Okay, so one instant cannot have two velocities at the same time, right? Two velocities at an instant cannot have, sorry, an instant cannot have two velocity at the same time. Okay, an instant, this is the instant, it has two velocities. Not only this, okay, even this 3 seconds or something like that, full of this, has two velocities simultaneously. They have parallelly, they have two velocities at the same instant. So you understood or not? Is it clear?
Understood.
Understood, sir.
Yes. Okay, what about C? I really hope whether Disha and Shruti can answer this one. What dimension? Who's that? Mrinalini. Okay, Mrinalini says it is one dimension. What about others? Disha says it's not. Thank you, Disha, for your participation. Very good. I asked Shruti to try also. What about Vishwa? Even Jayashri, you can tell, ma. Everybody can tell, no problem. Okay. Auxilia is silent, I guess.
Sir?
Yeah, Auxilia, you're silent now. Yeah,
Sir, I think it is not a straight line motion, sir.
not one dimension. Okay. Disha said it's not a one dimension motion. Mirnalini said it's a one dimensional motion. Okay. And Auxilia says it's not a one dimensional motion. What about others? Anybody? Anybody else wants to try? Jayashri?
Sir, not dimensional, I think so.
Not one dimension. Okay, very good. So yes, it is not one dimensional motion. It is not one dimensional motion. Why? It's very simple.
Negative, positive and negative direction.
Very good. Speed is negative here. Who's that? Who's that, ma? Who has said it right now? Who's that? Jayashri?
Jayashree, sir.
Okay. Here see, speed. It is positive here, but here it is negative. Okay. What we have learnt in motion in a straight line, distance is always positive, and
Yes,
speed,
sir.
yeah, speed is what? Always positive.
Positive.
Here it is not positive, so it is not a one dimensional motion. Very good. Very good, Jayashree, Disha, and Auxilia also. She guessed it right. Okay. So what about D?
It is a one dimensional motion, sir.
Okay, it is one dimensional motion. What about others? Auxilia
Yes,
said
sir.
it.
One dimensional, sir.
That is Jayashri, I guess. Okay. Disha, Murnalini.
So the
Yes.
distance is decreasing, so it's
Who is
not, it
this?
may be not.
Who is this, ma?
Disha, sir.
Disha. Okay, okay, yeah. Okay, Auxilia and who that is? Jayashri said it is a one-dimensional motion. Disha says it's not. And Disha is very much right. It is not a one-dimensional motion. It is not a one-dimensional motion. Why? Because here, what is total path length meaning, Jayashri? Other name for total path
Total
length?
distance covered, sir.
Yeah, distance. Total path length is nothing but distance. See here, the distance increases. Let's say it is 0, 5, 10, something like that. Okay. And after attaining 10 meters, it is decreasing, right? Yeah, that is 8, 9, 10, 5, 6. See, it becomes 0. And then again it increases. So, what we have seen, distance never decreases. Distance never decreases. Okay. So, that is why. For example, Disha, you there?
Yes, sir.
Yeah. Just try this one. Forget this as total path length. Okay. Now tell me whether it's a one dimension or not. So x-axis represents position. Y-axis represents the position x, and x-axis represents the time seconds. Now tell me, everybody for that matter, is it a one dimension or not?
Yes, sir.
Auxilia, no?
Yes, sir.
Okay. So Auxilia says it is one dimension, I guess. What about Disha? Jayashri? This is a position time graph, that is xt graph. Okay. Now tell me whether it's a one dimension or not. So you have to understand the concept clearly. Then no sums can test you. You can very well answer any of the sums. Any type of sums you can solve by yourself. See, I'm taking like this is okay. This is 0 meters. Okay, this is something like 20 meters. Okay, and it's again 0. Okay, it again 0. Okay, and here also the same thing, 20 meters. Okay, now uh, I'm calculating position. I'm sorry, I'm describing only the position here, or sorry, I'm calculating only the distance here. Okay, forget. So I'm calculating the distance. Okay, now 0. Okay, 0 to 20 meter. Jayashri, Jayashri, you there?
Yes, sir.
Okay, I'm assuming this 20. No, this is a point P. Okay, Jayashri.
Yes, sir.
Okay, now what is the formula for this? I can say OP, okay, O to P, right? O to P plus P to O. This is O, right? Right? And what? O to P. Am I right? The body travels
Yes,
from O
sir.
to P. O to P, that is 0 to 20. P to O, 20 to 0, right? And O to P again. You understand, Jayashri?
Yes, sir. Yes, sir.
Okay. So, what is the distance here? Total distance traveled.
60, sir.
Okay. So O to P is what? 20, right? Okay.
Yes, sir.
And now it comes here. Okay. The graph is decreasing. I'm just telling the graph, only the graph. Okay. So that is we are calculating P to O, right? So that is what? That is also 20, right, ma?
Yes, sir.
Okay. But what you have to decrease only, no? The graph is increasing. That is the graph is decreasing. Why are adding it 20 to 20?
Negative symbol becomes.
No, negative not is not negative actually. See, the graph is decreasing. They have shown like a graph is decreasing here. Okay, but
Yes,
what we
sir.
are doing, we are adding. We are not subtracting. We are adding, right?
Yes, sir.
Because we will add it. No, because distance will only increase. Distance will only what?
Increasing.
Increase. Because here it has obtained 20 meter, and it has come to here 0 meter. Okay, so what is the, let's say, just forget about this. Okay, what is the total distance traveled?
40, sir.
40. Very good. Total distance traveled is 40, right? Let's say this is position. Okay, if position means, what will happen here? 0 to 20. What is the position here? It has started here. It has come to 20 meter. Okay, now it has come here. What is the position here?
0.
0. Yeah, so you understand the difference right now between the position and distance.
Yes, sir.
When you calculate the distance, you do what? You add it. That is 0 to 20 meter. That
Adding,
is,
sir.
yeah, 22. That is 0. 20 to 0. That becomes another 20. So the total distance traveled is what? 40.
40.
Yeah. But while calculating position, what we'll just answer only the position. Okay. So here the position is 0. You understand?
Yes, sir.
Yeah. So now they are asking only the total path length. That is, here they have given the x. There is a y axis represents the total path length. Here it varies with time. Now you tell me, these are all path length. That is 0, 10, 20, 30. Okay, like that. Now can the distance decrease? Here they're showing it as decreasing, right? It is going to 20. From 20 it has become 10, 5, 0. Now another again 5, 10, 20. Is it possible?
No, sir.
Yeah, distance can never decrease, right? It can only increase. Even if we go like, we have seen in the, that is 0 to p. That is what? 0 to p is 360 meter. Do you remember OP plus PO?
Yes, sir.
What we'll do? OP plus PO is what?
Added, sir.
750.
720.
720.
Yeah, but we don't like, see, this is in the positive direction. OP is positive direction, but PO is in the negative direction, right? But
Yes,
since,
sir.
but what we'll do? But we are just adding only. Okay, while calculating distance, we are only adding. That is, it will always increase. So that is the thing. Okay. So is everybody clear with this? Disha, Jayashri,
Clear,
Mona,
sir.
clear. Okay. Vishwa, same
Understood,
here.
sir.
Yeah. Okay. Okay. So yeah. So we'll see tomorrow. I think tomorrow we have class. Day after tomorrow we'll have class. Okay. So okay. So we'll see in the next class. Okay.
Yes, sir.
Yes, sir.
Okay. Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, ma. You can leave the class. Thank you.
Hello,
Yes.
hello, sir.
Yes. Yes, ma'am.
Sir, in the fourth part,
Yeah.
you changed it to displacement. What is the answer for that? Like,
Just
is
a
it
moment.
is it not?
Just a moment. Just a moment. Yeah. Tell me, ma. Here. Here.
Yes, sir. In
Yeah.
the D
Yeah.
part.
What? Yeah. What happened is, this is total path length. Your good name? Sorry. Your good
Disha,
name?
sir.
Disha. Okay. Okay. Yeah. See here, the total path length is here, and this is time. And here it shows like, the path length is decreasing with time. Okay, which is not possible. So we are saying it is not a one-dimensional motion, right? I'm saying, what if I, scratch this path length and make it as position along y-axis? Okay. So what you will say, whether it is a one dimension or not? You getting it? See, if the y represents the total path length, you are saying it is not a one-dimensional motion because the graph is decreasing with time, which is not possible with distance while calculating distance. I am saying, okay, that is okay. So in this same diagram, I'm taking this total path length away. I'm just specifying it as position, this y-axis. Okay. Okay. And this x-axis seconds. So what will happen? Does this graph, the position and the time graph, represent one-dimensional motion or not? You can think until, no problem. Only one question to answer your doubt, Disha. Just answer me. Can position decrease with time? Can position decrease with time, Disha?
Yes, sir.
Okay. In one-dimensional motion, can position decrease with time? Tell me. No problem.
I think yes, sir.
Okay. You should not think. You should be sure. See, for example, we have seen the motion of a car, no? 0 to P. Okay. 0 to P is 360, right? In the 40, 80, like that it goes. Right, ma'am? It's not one dimension because it comes backwards. Mrinalini, you're saying for total path length or the position? The scenario which I have given now. Wait, I can even show you this example. No, I have it here in my. Yeah, it is there. Yeah, just. Do you see my screen? Do you see
Yes,
my
sir.
screen? Yeah. See, this is the positions. Okay. This 40, 80, 120, 160 are positions. Okay. I'm saying OP. I'm saying OP plus PQ. Okay, Disha. You follow?
Yes, sir.
Okay. Now the body goes from O to P. Okay. Is OP plus PQ is a one dimension or not? Just tell me that. O to
No,
P.
sir.
OP plus PQ is not one dimension. Why? OP. Okay. The body has come start from O to P. Okay. Then it has come from P to Q. Is it one dimension or not?
Yes, sir.
Yes, it is one dimension. It is straight line motion only now. Okay. So here what happens while going from O to P? The position is increasing now 40, 80, 120, 160, 230. And it has come here. Okay, Disha, you understand? O to P.
Yes,
Yeah. Now P to Q, what happens? The body was at 360-meter position. Then it comes to 320. It comes through 280. It goes to 240. Sorry, 240. That is Q position. Okay. Okay, Disha.
yes, sir.
Okay. Here the position decreases or not?
It does, sir.
It does. Yeah. It is one dimensional motion. Here the position decreases, right?
Yes, sir.
Okay. Just keep that in mind. Just a moment. So here, where is it? Here what happens? I said this is position. If it is position, it increases. Okay. Let's say this is 0 to 20 meter. The position increases from 0 to 20 here, and it decreases. Okay. It is 19, 18, to 0. And again it increases. Whether it is possible in one dimensional motion or not.
Yes, sir.
So position can decrease. Position can decrease, right? So this is a one dimensional motion. Okay. Similarly, just a moment. Similarly, here I'll just take that. Yeah, the same example. I'm saying this is distance. This is PQ. So what happens O to P? 360 meters, right? And P to Q is what? P to Q is what, ma? From P to 320 is what? 40 meters, right? From here to here, 40 meters.
One
Yeah, 40 meters and 40 meters. So P to Q is what? 120 meters.
120.
Yeah. So what we'll do? We'll just increase it. That is, we will add it up. That is, that O to P is 360, then plus 40, plus 40, plus 40. So it becomes what? This is 120. P to
480,
Q
sir.
is, yeah, 480. So you understand the difference here?
Yes, sir.
So while calculating distance, okay, we will add it up, because distance always what? It always increases. Okay, but while calculating position, okay, position can decrease. Okay, you understand?
Yes,
So
sir.
yeah, so from P to Q means the position has changed from 340 meter to 240 meters. But while calculating PQ, what is what? P to Q is 120 meters. We'll just add it up. That is, sorry, 120 meters, 360, 360 plus 120. So it becomes P to Q is what? That is, OP plus PQ is 480 meters. You clear?
Clear, sir.
Right. Okay. Okay. So that is what it is about. Okay. You still have any doubts?
No doubt, sir.
Okay. Okay. Yeah.
No, sir.
Right, ma. Right. Okay. So we'll see in the next class. Okay.
Thank you, sir.
Thank you, ma. Thank you.
Thank you,
Thank you.
sir.
Thank you. Thank you.